Up to now, a variable could only hold one value. That changes with a new kind of variable, arrays. Imagine you are building a system to manage bank accounts, or users in a video game, or students in a class. In those cases, you would need to manage a lot of things that are of the same type. Suppose we were interested in the ages of students in a class. It seems like we'd need a variable for each student's age. This code shows what it would be like for a class with 3 students. Imagine what it would be like for a class with 100 students. And with this strategy, we'd have to have different code for each possible class size. Clearly, that isn't going to be manageable.
You have a bug. Remember that integer division versus real division thing?
Oops, you were right. Thanks for catching that, Zumi. When we declare a variable to be an array, we are telling the compiler that we want it to be able to hold a bunch of things of that type. We do that by putting square brackets after the type in the declaration. After we have declared it, we have to tell the machine how many values the array should contain. We do that with a new statement. This one will give the array named ages space to hold 3 integers. Once the array has been created, we can access any position in it by putting the position number in square brackets after the name of the array.
Wait, I'm not getting this. We need a way to envision what's really happening.
Just like with regular variables, memory diagrams can help us understand. Let's look at that in more detail. When we declare an array, the compiler doesn't know how much memory it needs because we haven't told it how many values we want it to hold. Anytime the compiler doesn't know how much space it needs, it just creates enough space to hold a reference.
A reference is just a memory address. It tells us where something is located in memory. So the memory diagram just gets a box that will hold that reference.
Right. When we use the new statement, that allocates space in memory to hold the right number of values. The new statement evaluates to the memory address of that space, and we store that address, that reference, into our array's memory location. When we go to access a position of the array, the compiler will get the address and then go to the requested offset from there. Once we have declared an array and given it space, each position acts like it's its own variable. We can access any position in the array by putting its position number in square brackets after the name of the array. We read that ages sub 2.
We call this indexing the array.
The positions are always numbered from 0. This assignment state will evaluate the right-hand side, getting 42, and store it at the variable on the left-hand side. This time, the variable is an indexed position of the array. Counting from 0, ages sub 3 will be this position, and the 42 will be stored there. We can index an array using any integer, including the results of a calculation. If we declare a variable named I and give it the value 2, we can index ages by the expression I plus 1. That will evaluate to 3, and this print line will output the value in ages sub 3, which will cause the 42 to be output. When we started down this path, we saw an example where we were calculating the average age for a class using individual variables. And that required a formula that had the sum of all of the variables in one place. That meant that if we were going to add one more student to the class, we would have to change that formula. That problem goes away if we store the ages in an array.
Be the machine.
In this example, we start out by declaring a variable named I to be an integer and have a 0 in it. And we do the same thing creating a variable named sum. I is going to be the position in the array that we're working on, and sum is going to be the running total of the ages so far. So they both start at 0. Now the while loop is going to let us look at each position of the array. So we want the variable I to go from 0 to the last position in the array. Java gives us array.length that you can attach .length to any array name, and it will tell you the number of positions in the array. So in this case, ages.length is 4 because there are 4 positions in the array, and they are numbered 0, 1, 2, and 3. So the while loop will first check to see is I less than 4. It is, because I is 0. So we go into the loop. In the assignment statement for sum, the right-hand side evaluates sum and gets 0, and then looks at ages sub 0, which in this case is 42, adds them together, getting a 42, and stores that value into sum. Then it increments I, getting the value 1, and it goes back to the top of the loop. It asks, is I less than ages.length? And 1 is less than 4, so it goes into the loop again. This time, this assignment statement is going to evaluate sum and get 42. Then it's going to evaluate ages sub I. I is 1, so that's going to look in the 1th position of the array and get a 14. It's going to add the 42 and the 14, getting 56, and store that at sum. Then it's going to increment I and go back to the top of the loop again. At this point, the variable sum holds the sum of the first 2 things in the array. So it is a running total. We've just only gotten through the first 2 positions so far. This time, it compares I to ages.length. I is 2, which is less than 4, so it goes into the loop again. It evaluates the right-hand side of the assignment statement. It's going to get 56 for the sum. And then I is 2, so it's going to look at position 2 in the array, getting a 19. It's going to add the 56 and the 19, getting 75, store that back at sum, increment I, and go to the top of the loop again. Now our running total has the sum of the first 3 elements in the array. I has the value 3, which is still less than 4, so we go into the loop. Sum is 75. Ages sub 3 is 17. We add those together to get 92, store that back at sum, increment I, go to the top of the loop again. This time, when it compares I to ages.length, they are equal, so I is not less than ages.length, so the loop stops. At this point, the variable sum holds the total of all of the things that are in the ages array. And the real power here is that my code didn't need to know specifically how many students were in our class, how many ages we were going to add together. We could ask the array its length and then look at each position in the array. So if there were 30 things in the array, we would have added all 30 of them. If there were 2 things in the array, we would just add the 2 of them. That means that our code doesn't have to be specific to the size of our class. When we want to store a bunch of values of the same type, we can use arrays. Setting up an array requires adding square brackets to the variable's declaration and using the new statement to allocate the memory for the number of spaces we want it to hold. Once it is set up, we can index the array to access any position, but we need to remember that the first position of the array is always 0.